All right. So everybody was able to get Alice installed and mess with it a little bit. All right. So I know some people got confused and they did all 7 of those tutorial things. Yeah, I basically just wanted you to do the first one to prove that Alice was installed for you. But if you did all 7, great. But I think there's a couple of weird things that happened somewhere in there because Alice went from version 3 to 3.1 to 3.2, and I think the video was on 3.0 and whatever. There's going to be quirkiness that we'll figure out, but in any case, I just wanted to make sure everybody was able to get it. And having said that, I don't even have it installed on my machine, but I do have it already downloaded, so we should be okay. Or I just proved that Concordia's internet is extremely fast. 1.5 gigabytes instantly. So do we have a favorite Super Bowl commercial? They haven't been as good for the last couple of years. What I've been wanting is, what I thought would be cool is, remember a couple of years ago, Volkswagen had the Baby Vader commercials where the little kid was dressed as Darth Vader and he was trying to use the Force, and then at the end he got the car to start because his dad, remember that one? Yeah. I think it would be cool, especially since Star Wars just came out this year, to have like a baby Kylo Ren one. Where it's just like a remake of that, but it's the new Vader, the new bad guy. And I thought that would be kind of interesting. I kind of like the sheep one, where it was about the, I don't even know why that makes sense though, the truck that has the music that plays out of the bed. Like, why would you want music playing out of the bed? Like, what's the point? Is that maybe when you're working?
Probably tailgating.
Oh, that makes sense. Yeah, I didn't even think about it. Yeah, you're smarter than you look, maybe.
I look pretty dumb.
Well, I was actually thinking that when I said it, but so that I'm just saying it's a low bar.
I didn't get the sheep, but I thought that would have been more sense if they had it, like a football game.
Yeah, right. Well, but the sheep was funny because you got the dog or the sheep, but they're always riding in the back of the truck, and all of a sudden they learned all these songs. I guess it would have been funnier if they would have sang songs that were like super, I don't know, like all the sheep were singing like Justin Bieber or something like that. I guess that would have been funny. Okay, so I think we're installed here. Oh. In theory, it's installed. Maybe just didn't index yet. All right, so we're going to mess around with Alice a little bit today, but I'm going to start talking about it in the context of variables, conditionals, and loops. Okay, so we want to kind of learn those things. It's interesting enough to sit here and kind of go through it and screw around with stuff, and we will do that. We'll have it doing some stuff, but initially we just want a tool that allows us to do this stuff. So I think the tutorial had you pick the swamp, right? So we'll do the swamp here. Okay, then they have you let's set up the scene, and then go and find the witch. So what was that, fantasy? Oh, here's our witch. All right, so and then they did the cauldron and stuff like that. But for right now, I'm just going to start with a single avatar, kind of on our screen here. All right, so just as a quick look, we can we can have the witch do different things. We have this thing here called edit code. Now, one of the nice things about Alice and kind of the point of Alice is that you get to do some programming syntax-y based stuff without the risk of the typos. Sometimes that turns into Alice preventing you to do something that you really want it to do, but more times than not, it's going to allow us to do some stuff that we maybe couldn't do otherwise. So when we do edit text, there's a bunch of stuff we can do in here. We're going to start off with just this, tell our which to say something. So we'll do our custom text hello world, because that's what we always have to do with every new program. And we'll go ahead and run. And there's our which yelling hello world. And that went by pretty fast. So whenever we do an action, and I'm going to talk about procedures and functions here in a second, but whenever we do an action, we have some options for adding some additional detail to it. And so here's like what the color of it is, outline color, font color, duration. We're going to make the duration last a little longer. We'll just set it at 10 seconds, hit play, and now it'll be a prolonged scream of hello world. So that's kind of our starting point, and this is the, that's the different, that's say, and then I think we change it to, I think does a little think bubble, dealy, flippy, majiggy. That one for 10 seconds. Yep. So. All right. So we want to talk about a couple of things here. And part of this has some historical precedence. So we talked about how human beings solve problems way back at the beginning. Memory, asking questions, and repetition. And we mentioned that every programming language is going to have a mapping. That is, it's going to have a facility for remembering stuff, a facility for asking questions, and a facility for repetition. Now, while Alice is a kind of a tool, not just a programming language, embedded within it is, I'm going to say, a kind of a beginner-ish programming language. You can actually accomplish some fairly complex things with it, but in general, at the very least, it gives us ways of remembering stuff, gives us ways of asking questions, and also ways of looping as well as functions. And we actually are already working within our first function because Alice kind of makes this assumption. So when we look at a scene, here's how the scene initially starts up. This is just hard-coded in, so don't worry about it for right now. But here's our initial event listeners. When the scene is activated, so when the app starts, if you will, the very first thing it does is it calls this method called myFirstMethod that it put in there for us. We didn't create that. It generated that for us. So myFirstMethod right now just says we want the which to go ahead and think hello world for 10 seconds. That's what that method says to do. And notice here this says do something in order. Okay? So if I had more than one task in here, so if I change this to say maybe 2 seconds, and if you went through all the 7 things, I think, don't they have the witch jumping up, screaming something or something like that? So just as a quick example, we'll just change this to so there after 2 seconds, the witch will then say woot or something. So it'll do these in order, not at the same time, because this thing said do these in order. So this is a linear walk through these steps. All right, so there's hello world for 2 seconds and then woot for 10. All right, so this is going through that process. Okay, so we're going to think of this for right now as this is our program. We're going to do everything around this which doing stuff, but most of it's going to be logic stuff since that's kind of what we're initially learning. And then we'll start making that logic translate into her doing things in the scene and that kind of stuff. So one of the approaches Alice takes is this idea that we're kind of telling a story, all right? And writing normal computer programs is the same thing. We're presenting an interface that the user can interact with. Right now our interaction is visual only, right? We're just watching the story play out. And then as it plays out, we have a measurement here that's time. So however long, right now our app runs for 12 seconds, right? Okay, so we're experiencing our application for 12 seconds, and during that 12 seconds, a couple of things are happening. All right, so think of it like a scene in the movie. And right now, we have one actor in our movie. In our more modern programming languages, we would refer to this actor as an object. Okay, remember, we talked about the difference between procedural languages and object-oriented languages. And in object-oriented languages, we think about the telephone as looking like a telephone. Well, now we have a witch object, and she looks like a witch. All right, and witch objects can do things. There's a bunch of stuff built into the witch for what she can do. So, we can have the witch point at something. We can move and orient to something, turn to face. These are all built-in things that kind of make sense if we're thinking about this like a movie, right? So there's some built-in actions that the witch knows how to do, all right, that we didn't write. They're just kind of provided for us. Just like human beings have a bunch of built-in stuff that we're capable of doing. All right, but we're not going to worry about too many of those things right now. What we're going to do is we're going to augment our witch with additional things. All right, so what I'm going to do here, I got to remember where this is. Is it that guy? Actually, I think it's on the witch itself. I want to create a new property for our witch.
It might be in the drop-down menu next to scene.
This guy? Oh, this guy. It is. It is actually. So we go to witch. We can add a witch property. So I want us to think of properties as being equal to variables. All right. So this is so in this language. Let's kind of go down here and just talk about Alice. We have we have memory being represented through something called a property. And specifically, properties belong to actors, or in our object-oriented terms, objects. Okay, so we're going to add a property to our witch, which is going to allow us to remember one additional piece of information related to witches. Let's go back in here. So we're going to add a witch property. And this guy's going to, so we have two options for this. We have variable fields and we have constant fields. Variable fields are things we want to remember that might change. Constant fields are things we want to remember that won't change. So for example, we could teach the witch about the constant pi, set it equal to 3.14159, and say, well, that's not going to change anytime soon, so that's going to be a constant. And underneath the hood, the language from a memory perspective might create that in a certain way, versus if we want it to be variable, it might store it differently because we're going to be making changes to it. Okay? But in this case, we're going to go ahead and make a variable field. And then we get to choose the value type. What kind of variable does this hold? Does it hold a decimal number, a whole number, a Boolean value, or some string? All right, so we have, we could also pick classes, and then there's some other types, but right now we're going to stick with our normal thing. So we're going to choose a whole number. All right. We are eventually going to talk about arrays. That's a collection type. But right now, just a single whole number. It's going to hold a single value. We're going to give it a name. So we're going to call this guy count. And then for the initializer, let's just start count off at 0. Okay. So now we see that a witch has a function called getCount and has a procedure called setCount. And this is actually set up from something a long time ago. So let me just go back in here, and I'm going to do asking questions. So we're going to kind of skip that for this exact moment. And then we went to repetition. And we're going to say loops in here with a question mark. They're supported in Alice, but I'm going to leave it like that for right now. But before, we had mentioned this thing called functions. Okay. Now let's talk about that through our history of languages just for a few minutes. So the evolution of function-like things. All right, so really at the end of the day, these are mostly synonyms of each other. And Alice actually makes the decision that's much more like the C programming language than even our more modern languages. So if we go way, 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 way back, these guys were usually called subroutines. Okay, so all of these guys are, here, let's just give a general definition for these real quick. Reusable named chunks of code that we write once and call multiple times. So if we go back a long time ago, these would have been called subroutines. Sometimes just subs. From subroutines, we got into this idea of procedures and functions. Procedures did not return a value. Functions did return a value. The way Alice kind of explains this is that procedures perform an action, but not necessarily, it doesn't do math or respond with any sort of value you could use for something else. Where functions are performing some sort of calculation and then giving us the answer. All right, so the difference here would be with a procedure, this guy knows we were given an initial procedure called set count. So when we created that property, we're given two different things. A procedure called set count that takes in a value for our count and sets our internal count variable to that. Then we have a function that returns for us the whole number variable, the whole number value for the which's current count value, count property. Does that make sense? So functions give us a value, procedures do something, not necessarily giving it, well, and they don't give us a value. Modern languages, specifically object-oriented languages, have combined procedures and functions into one animal called a method. And methods have a return type that may be void. So a method that has a return type that's void is like a procedure. It's something that does not return a value. But for Alice, they separate the two. If we're gonna have something that does something without returning a value, it's a procedure. If we have something that very well might still do something but does return a value, it's a function. All right? So what we want to do is instead of the witch saying hello world, we want the witch to tell us what her count is. And remember, she's remembering some things, so we're gonna have her think about this. So we're gonna have the witch think, and what's she gonna think? She's going to think this guy right here. Count is equal to kind of screwed that up. I want this guy. Can I not drag that? Oh, can't drag that. So count is equal to, and then the value we're going to have it set to is the witch's get count. All right, so the witch is going to think something, and what she's going to think is the string count is equal to, and then the plus sign is for concatenation. It allows us to build kind of a sentence. All right, so the count is equal to, and then this will retrieve for us the witch's current count. All right, and we'll do that for 2 seconds. So when we run this, the witch should say count is equal to 0. All right, so the witch has now proven to us that she can remember some stuff. Make sense? All right, so that's the premise for variables. Now, just because she remembers the count doesn't mean we're actually applying it to anything yet. So we want to think about now maybe incrementing that count, making it go up or something like that. So let's go ahead and let's change the value of count. So we're going to go ahead and, oh, I can't do that for properties there? That's fine. So we're going to go ahead and use this witch's, well, I'm actually going to start it off as 1. So we're going to have the witch set her count to 1. And then I'm going to copy this. Oh, can't copy yet. Can we duplicate? Oh, it says we can copy to clipboard. Oh, here's the clipboard. Oh, I get it. Okay. All right. So if you want to copy something, you right-click, you copy it. It hides it inside the clipboard here. Then you can drag it out here to that. Well, it saved us some typing. All right. So now for 2 seconds, we'll say what the count is. So it'll say 0. Then we'll modify the count to be 1. We hard-coded it to a 1. And then we'll print out what the count is again. We'll think the count is again. So we'll have it as a 1. So there's our 0 for 2 seconds. And then there's our 1 for 2 seconds. We're modifying our memory. Okay, and that's a permanent modification. So when we change the value of count, we overwrote the 0 with a 1, and now it's a 1 from that point forward. All right, that makes sense? So this is memory. This is variables. We're doing it in Alice, but it's no different in Java. It's no different in C#. It's no different in C. They're all the same. We can create variables. Variables have values associated with them, and by definition, variables can change. And when we use a variable, it resolves to its most local, or for its most recent definition in our world right now. Eventually, we're going to be talking about this idea of scope, and that's where that local thing will come in. But for right now, it's its most recent value. If we change it to a 1, after we change it to a 1 from that point forward, it'll be a 1. Okay. Now, so that's us remembering some stuff and modifying what we're remembering. Now, it'd be nice if we can have the witch count up. All right. And what that's going to require us to do is it's going to require us to, instead of setting the count to a literal, so like 1, 2, 3, these are literal values. They're not based on another value. So all of us inside of our heads, we have kind of hard-coded values. We have all the letters of the alphabet, we have all the numbers, so on and so forth. All right, so when we set count to a literal, we're not basing it off of anything that's happening in the rest of the witch's memory. What we might want to do is we might want to set the count to be 1 bigger than it used to be, which will require the witch to remember what the current count is, then add 1 to it, and then set that value back into her memory. Okay, so let's go ahead and do that. So we're going to change this count here to some math. All right, and the math we're going to set it to is going to be, for right now, we kind of have to, I think we have to kind of fake this a little bit. I'm going to do 1 plus something. Well, actually, this is fine. We want it to be 1 plus something. I'm going to say 1 plus 1 for right now. And what we're going to do is we're actually going to change one of these values because we actually want it to be the current count plus 1. But this was kind of my way to get it out there. There might be an easier way that Alice lets us do it. Well, so since we want to get the value of 1, that's going to be in our functions, right? Functions give us values. And it just so happened when we created that property under functions, we have the ability to get the count. And I can drop it, it looks like in either of these. So I'll drop it right here. So I want to set count equal to the current count plus 1. Make sense? So we'll go ahead and run this again, and we're going to see that indeed we get the exact same output as we got a second ago, but we got to that output a little bit differently. So there's the 0, and then there's the 1. Okay. Now, we might want to incorporate some repetition in here. We could certainly just keep copying these lines over and over again. I can copy this one and then print it, copy this one, then print it, and see her count up from 0 to 4 or something like that. And then we're going to get kind of tired of cutting and pasting stuff, especially when you consider that we have to drag in from the actual visual clipboard. But we want to mess around with some loops. So we want to do something some number of times. So down here we have some repetition constructs. So notice that we are currently inside of a construct called do in order. That's the starting point for all of our methods, is a do in order thing. But now we hit a spot where we really want to repeat some stuff. And we have a couple of options. We can either repeat it some number of times. So let's kind of define this. We can repeat it some number of times. We can repeat it until some condition is met, which is going to require us to learn how to ask questions. Or we can do it once for each element in a collection. I kind of mentioned a few minutes ago about arrays. All right, so we're not going to look at that one yet, but right now we're going to do something some number of times. So we're going to count, let's do 10 times. Hit OK. So we're going to do something some number of times. What are we going to do? We are going to have the which say the current version of value of count, and then add 1 to it. Go ahead and delete this. So now we're going to repeat something 10 times. The which is going to, for 2 seconds, say count, and then we'll change count to 1 greater than it used to be. So now we should be able to see the which count up from 0 to 9. Let's make this a little quicker so we don't have to wait as long. All right, so now we're leveraging this idea of repetition. All right, performing some action multiple times. Okay. Now we want to think about asking a question. All right, so filling this in. So right now we've been introduced to, one kind of loop, the count. So here's our loops. So right now we have actually let's just put it underneath this. So for repetition we have the count loop, which does something a fixed number of times. All right, we're about to learn about asking questions. Okay, so if you remember way back when we talked about that mapping, we said that conditionals are usually if statements, because all of our modern languages came from C. Same thing is true here with Alice. So we'll close this. Down here, we have another construct here. So this is an if, and I'm just going to throw a condition in there right now, true. Okay, we'll modify that here in a second. So what we want to do now is we want to have the which, after she says the number, we want to have her go ahead and say whether it's even or odd. Fair enough? Okay, kind of which can prove that she knows how to do some math. All right, so we need to figure out how do we ask the question. So the way if statements work is we say if the answer to a question, this guy is a Boolean expression. So let's give some definition to that. We use Boolean expressions in our more complicated loops like the while loop as well as conditionals. So here's a Boolean expression. This is any expression that boils down to a single value of true or false. Okay, and sometimes Boolean expressions can look fairly complex, but at the end of the day, they still boil down to a single value of true or false. So for instance, I can say if it's cold outside or it's sunny, I'm going to do something. All right, that looks like a fairly big sentence, but ultimately that whole Boolean expression will boil down to either a true or false as to whether I will do something. Okay? So that's what Boolean expressions are. So if we were going back to our syntax here, this is saying if some Boolean expression. And let's see what it lets us modify it to. Oh, we could just randomly pick a Boolean. That's kind of nice. Alice just lets us flip a coin, essentially. Yeah, let's actually do that. That might be kind of fun. So we'll have the which just say true. For a second. Otherwise, we'll have the which say false for a second. And we're going to drag this stuff down here. We'll come back to it here in a little bit. And we'll put this question inside here. So this will have us generate 10 random Boolean values. Each time through which will tell us what the value was, true or false, just by responding. So if the value was true, say true. If the value was false, say false. Okay, so that's the if and the else. And the hope is we should get a relatively even distribution of about 5 of each, or maybe 6 and 4, or something like that. So we got a false, a true, a false, a true, a false, a true, a false, and a true. I think it was, what, 6 to 4? So, not horrible. Okay, so that's some just generating random Booleans that might be helpful for us, but we want to probably do something a little bit more interesting. We want to be able to ask a question. So we can ask if something is not true. Right here, we can ask if two things, if both are true, if either thing is true, so this is an and versus an or, okay? And then here, so this is kind of a specific where they're saying, we'll go ahead and automatically generate a random Boolean for you so that you can have, like in a game, you might want to have something kind of randomly occur. Maybe have a little bumblebee or something like that. He switches directions kind of at random. Something like that. We might not want to have to put a whole lot of thought into that every single time we want that to happen. Or we can do something pretty specific here. We can also do, here's kind of our mathy stuff. So we can say if one number is less than another number, do something. Here's our whole number stuff. Oh, this is going to get kind of interesting. Do we not have modulus in Alice? Oh, it's got to be there. All right, we'll figure it out here in a second. Well, let's look here real quick. That's going to be a buzzkill. Alice modulus. So modulus gives us the remainder of an integer division. I didn't see it in there. Suppose we might need to fake it. Well, I guess let's keep searching in here, but let's just build a normal thing first. So we're going to say if count is we'll start by putting a 2 in there or something. All right, so what we want to ask here is we want to find out if the which's count is less than some other value for right now, and then we'll see if we can change this to something else. So to get the which's count, we have to go to our function, which's count. So we'll throw that in there. And we want to find out if it's less than, let's just go ahead and give it a whole custom decimal number. So we'll say less than 5. And then we'll have the which yell out, less than 5. Otherwise, greater than or equal to 5. All right, so 10 times, the which is going to go through, ask this question. Now what we want to do, though, is every single time. Notice this is not part of the if else. So every single time through this loop, we want to ask this question, respond accordingly, and then regardless of how we responded, we want to go ahead and change the value of count to be 1 greater than it used to be. All right, so see how these got separated? This would be very different than if we threw this value inside the else there. All right, so we want to keep those guys separate. No matter what the answer ended up being, we're going to go ahead and update that. So we'll go ahead and, as well, should show it less than 5 times, so on and so forth, and then we finally should get our 10 at the very end. Okay, so we're able to go through and do that stuff. Now let's see something here. Can we... that's all relational stuff. We want mathy stuff. So where is my mathy stuff? That's where modulo would have to be. We can also do text comparisons if something is equal to something else or starts with something else or that kind of stuff. We did some math stuff here. Where did this guy come from? This is a custom math thingy. Here's division and remainder, so we do have it. We have an integer remainder of something. But how do I get that in my... Oh, I know how to do this. Okay, so we need to change this up. We want to check to see if a value is equal to something. We want to know if it's equal to 1. Just leave it at that for right now. And then we're going to change this value. So when we take the current count and we divide it by 2, and we look at the remainder, if the remainder is 1, it's an odd number. If the remainder is 0, it's an even number. Because any value divided by 2 will have a possible remainder of 0 or 1. It can't have a remainder of 2 because 2 would have gone into the number again, right? So this idea of modulus is pretty important actually in computer programming, and it's something you probably learned in 3rd grade math. Remember long division? That guy? So we use it pretty often. So this is modulus, the remainder of integer division. So any positive number n, and I'm going to use the modulus symbol that's used in most high-level programming languages. Alice has their own built-in little don't type, just drag function thing for this, but most programming languages use the % symbol for modulus. So any positive number n mod a positive number, let's say D, will have an answer range of 0 to D minus 1. So if I mod something by 2, it'll be 0 to 1. If I mod something by 10, it'll be 0 to 9. Those are the possible remainders you can get from integer division. You can't have something divided by 10 have a remainder of 10, because that means 10 actually went into it another time, which means that you did bad division. You got the wrong other answers, which gave you the wrong remainder. All right, so to determine if a number, so if we think about even and odd, for example, we know 5 is odd. So if we say 5 mod 2, well, 5 divided by 2 is 2. 2 times 2 is 4, with a remainder 1 to get back to the 5. So this has a remainder of 1. So all of our odd numbers would have remainders of 1. 7 mod 2. Okay, 2 goes into 7 3 times. 3 times 2 is 6. Remainder 1. Even numbers are all going to have a remainder of 0. 2 goes into 4 2 times. 2 times 2 is 4, with remainder 0. 6 mod 2. 2 goes into 6 3 times. 3 times 2 is 6, with remainder 0. All right, so we just have to do the modulus math, look at the answer to it. If it's 0, it's an even number. If it's 1, it's an odd number. Okay? So let's compare this guy to, well, we'll just compare it to 1 since that's already a drop down. Then we want to change this guy to math. And the math we're going to do is division math. Let's see. That's weird. We had the right kind of math before. Well, let's see what happens here. Change it to that. And we want to find out if the current value of count when divided by 2. So here's our current value of count. We were able to get modulo down here. Where did that come from? Yeah, we have this division and remainder thing in here. I kind of want that guy up there. I want to do an integer remainder right here. That seems unfortunate. To like hack this to get the right value. All right, so it looked like we started with the plus sign before. That's what we had down here. We essentially have the count plus a number. How do I get modulus here? That's the whole Boolean. This is the math formula we're doing. We really want it to be a division-based one, but we want it to be this kind of division-based one. Division and remainder. Could we do, oh, I think I got this. So I bet you we need to reduce to only the left operand, like that. Then we have this one, we can update the math. Oh, I really thought that was going to work. How do we get, so that's for our count. So which get count down there, we can do division remainder. But which get count up here, we can't. So because it's in a Boolean? Yeah, so I was thinking, so can we do, oh, I think we need to put that in a variable first. Just do it down here. We'll set it to 0, but then we're going to replace that 0 with this guy. And we'll actually change that to math, division, and remainder, integer divide 2. We'll just set them both to 2 right now. Okay, so we want to get the current value of this guy, and we want to divide it by 2. All right, so this is the thing we want. Can we put that up there? Right there? No? Well, that's troubling. Okay, well, hesitant to give an assignment based on something that I'm not 100% positive you can do, but seems very likely you should be able to do this. So why don't we do this? I'll put the assignment up. Go ahead and let's have the which count down from 10 to 0 and print the value out. So we'll leverage what we did today, but have a loop that goes backwards. And between now and next class, I'll figure out how to make this Boolean operate on this modulus as opposed to it working everywhere but in there.